Okay, I'm going to draw a circuit based on the 4093 NAND gate chip. And this is a simple oscillator, but that we're going to design here. And so first thing it has is I have a 1K resistor. This limits the ultimate frequency of the oscillator. Then I have a variable resistor here, and I usually would use a 1 meg, well you could use a 100K or some other amount. Then we have a capacitor down here, and this would be about 0.1 microfarads, and that's the rate of charging of this capacitor is controlled by the current flowing through the variable resistor here. And so this resistor controls the frequency of oscillation. Then up here we have a switch, and normally this would be connected to the positive voltage, but we could also have it connect to a input signal from one of the other oscillators, and so in that case we'd get frequency modulation oscillation. And then over here we can also have this connect to another capacitor, a larger capacitor, maybe 10 microfarads. But you could try either 1 microfarad or up to 100 microfarad for that one. And then a third thing we can do is have a diode coming as an input from another oscillator, and that would make an oscillator sync, because then these capacitors would be able to discharge through this diode when it was in the correct state. Okay, then over here on the output, I could go straight out now, but since we're playing with the circuit here, one of the things I could do is put in a VCA made out of a 5457 FET, and then this has to have a couple of resistors on it. We have one that goes to the, this is a 1 meg going to ground, okay, and then over here we have a 470K, and this is CV control voltage in for the amplitude of the this is actually forming a VCA, voltage controlled amplifier. And then over here this side also has to have a connection through a 100K to ground. Okay, now if we didn't want to use this, we could have a switch to bypass it like that. And then the other thing I started thinking about was maybe I could have like a low pass filter on this. So I'm going to have a diode, I'm going to have a variable resistor and a capacitor to ground down here. And then I thought, well, you know, if I put another one in the opposite direction, then I could have this one before sort of the attack, and this one could sort of form the decay. So this one would cause it to rise up sort of slowly instead of going straight up and down, and this one would cause it to decay sort of slowly instead of just a sharp decay. Alright, and these would probably both be 1 meg, and this one is to be determined. And then we go to, okay, next part we'll have is I would usually have a output indicator through an LED to indicate when the circuit is on, and that would go through a resistor to the positive voltage. But let's see, I want to add a resistor in here probably so that I don't cause a short. So I'm going to put in a 1K right here, and then I'm going to tie this over to there. Okay, good. Now for the regular output, I'm going to have a variable resistor here. I'm going to tap off of that to provide my regular output. But I'm going to have another output right here, and I'm going to have a option to switch this. Instead of disconnecting it like that, I'm going to switch this, have it on a switch, so that I could also have another input on here for an envelope, because this will become the swing VCA, which has sort of interesting properties. So if I connect this, instead of just plus voltage, I connect it to an envelope, I'll get this one to act like a swing VCA, and get that output up there, get a regular output down here. I've got two outputs. Oh, the only thing I forgot to do was over here, I need to put in some voltage control for the frequency, and I'm going to provide that with the we'll do the same thing as our VCA for 70K coming over to an input, and this will be for the frequency, control voltage for the frequency, and then we have another 1 meg over here to ground, and we have in this case this would be going over towards ground, so that is the source, and this is the drain, and in this case this one's going over towards ground, so that is the this one's going over towards ground, so that is the source, and this one is the drain, and that is like that. Okay, so that should do it. So those are all the features. So some of the features I have are, it's basically an oscillator, but it can act, you can control the attack and decay of the output. You have opportunity for frequency modulation, oscillator synchronization, and amplitude modulation. And swing VCA output, as well as regular output. And you can also modulate the have CV control on the frequency as well as the amplitude. Okay, that's it.